Bismillahirrahmanirrahim. Assalam-o-Alaikum viewers. Welcome to Explore More Mathematics YouTube channel. Today we are going to discuss about solution of simultaneous linear equation. But first of all, you have to learn about which equations are said to be linear equations. Those equations in which involving variables having degree 1 or involving variables having power 1 are said to be linear equations. For example, we have two equations, ax plus by is equals to m and cx plus dy is equals to n. We have these two equations, and in these equations x and y are variables. These variables are having power 1, so these equations are said to be linear equations. And we have here the system of two linear equations in which two variables are involved. Two variables are x and y variable, and a, b, c, d, m and n are real numbers, or we can say that these are constants, are real numbers. So we have system of two linear equations, the variables involving here x and y having power only 1, and this is the system of two linear equations, and this system is also said to be simultaneous linear equations. So we have two methods to solve these type of equations. First method is matrix inversion method, and second one is Cramer's rule. When we go further in the video, we will discuss how to solve these two equations in matrix inversion method and Cramer's rule. The first method is matrix inversion method. Consider the system of linear equation, and we have two equations, ax plus by is equals to m, cx plus dy is equals to n. We will resolve these two equations in the form of matrices, where the first matrix is the matrix A, B, C and D, and this matrix is the matrix of coefficient. A, B, C and D. A and C are coefficients of x, B and D are coefficients of y, and since we know that these values are constants and coefficients, so we have to set that the first matrix is the matrix of coefficients, the next matrix is the matrix of variable, and the variables are x and y, and it is equals to the constants which are on right hand side m and n. The last matrix is m and n, and we write it on our right hand side. So we write these equations in the form of ax is equals to b, where a is the matrix of coefficient, x is the matrix of variables, and b is the matrix of the constants which are present on right hand side. We have to find the value of these two variables x and y. So x is equals to a inverse into b. A inverse is adjoint of A divided by determinant of A into B. Determinant of A is AD minus BC. Adjoint of A is D minus B minus C, and A adjoint can be obtained by interchanging the diagonal entries and changing the sign of other entries. So adjoint is this D minus B minus C and A, and we have the matrix B. If we multiply these two matrices and divide with this determinant, we can get the values of the coefficient, we can get the values of variables x and y. The next method is Cramer's rule. We have two linear equations, ax plus by is equals to m, cx plus dy is equals to n, and we resolve these two equations in the form of matrices. The first matrix is the matrix of coefficient, the second matrix is matrix of variable, and the last one is matrix of constant. X is equals to A inverse into B, and it is equals to adjoint of A divided by determinant of A into B. If we multiply adjoint with this matrix, we form these types of entries. Or you can say that x is equals to ax determinant divided by determinant of A, and y is equals to ay determinant divided by determinant of A, where ax is equals to mn and bd. This is a 2 by 2 matrix where the first column is this matrix, or you can say that the first column is the column of constant m and n, and it is said to be ax, and ay is equals to ac, m and n. It is also a 2 by 2 matrix, but the second column is the column of constant. In the whole this Cramer's rule, you have to understand ax and ay, because when you will solve questions or examples related to this Cramer's rule, you don't have to solve all this procedure, but you have to understand x and y, and you have to learn it by heart, and what is x and what is y, because when you understand that values of variable x and y, you don't have to solve all this procedure, but you have to write x and y and the values of ax and ay. Ax is a matrix which is 2 by 2 matrix. The first column is column of constant, and in ay it is also a 2 by 2 matrix, and the last column, or you can say that the second column, is column of constant. So when we solve examples related to Cramer's rule, you will understand this whole procedure really clearly, and when we solve the example related to matrix inversion method, you can also understand that example very clearly. So let's start the examples. The first example is solve the following system by using matrix inversion method. It is the first method which we have discussed, and now we will understand the method by the help of an example. We have two equations, and these equations are linear equations. 4x minus 2y is equals to 8. 3x plus y is equals to minus 4. The very first step is to convert these two equations in the form of matrices. The first matrix is the matrix of coefficient, the next matrix is the matrix of variable, and the last matrix is the matrix of constants. So the matrix of coefficients is 4, minus 2, 3 and 1. The coefficient of x is 4, the coefficient of y is minus 2. When you are writing the coefficients, you have to write the signs according to the coefficients. Here 2 has the minus sign, 3 has the plus sign, and 1 has also the plus sign. So write signs according to the coefficients. Here is the matrix A, which is 4, minus 2, 3 and 1. The next matrix is matrix X, having values x and y, and the matrix B is a matrix having values 8 and minus 4. X is equals to A inverse into B. A inverse is adjoint of A divided by determinant of A. There is a separate video on finding inverse of the matrices. You can also watch that video and understand the topic clearly. So A inverse is adjoint of A divided by determinant of A. Determinant of A is equals to 1 multiplied by 4 minus into minus 2 multiplied by 3. And 4 1s are 4, minus minus plus, 3 2s are 6, 4 plus 6 is equals to 10. Since it is not equals to 0, so we will find A inverse. Adjoint of A is equals to 1, 2, minus 3 and 4, and this adjoint can be obtained by interchanging the diagonal entries. Since the diagonal entries are 4 and 1, now we will interchange the sign of these two. We will interchange these two entries and replace these two entries. 1 is on the first position and 4 is on the last position, and we will change the sign of other diagonal entries. Here you can see that 2 has minus sign and 3 has the plus sign, so we will change the sign. 2 is positive and 3 is negative. So adjoint of A is equals to 1, 2, minus 3 and 4. Now in this first equation, write all the values, value of adjoint, value of determinant, and the B matrix. So x is equals to 1 divided by 10 into 1, 2, minus 3 and 4, and this matrix B 8 and minus 4. Now multiply these two matrices to find x and y, and when we multiply these two matrices, we can get a solution. X is equals to 1 divided by 10 into, multiply the matrices as first row with the column 1 into 8 minus plus 2 into minus 4. Now the second row with the first column minus 3 into 8 plus 4 into minus 4. It is 1 divided by 10. 8 1s are 8, plus minus minus, 4 2s are 8, and 8 3s are 24, minus 24 plus minus minus, 4 4s are 16. 1 divided by 10, 8 minus 8 0, minus 24 and minus 16. Answer is minus 40. Now when we divide this 10 with these two values, the first value is 0 and the last value is minus 4. Minus 40 divided by 10, answer is minus 4. So x is equals to 0. Small x is equals to 0 and y is equals to minus 4. It is the matrix inversion method, and you can say that it is the first method to solve the simultaneous linear equation. If you have any question, queries, do ask me in the comment section. The next example is 3x minus 2y is equals to 1 minus 2x plus 3y is equals to 2. The matrix A is the matrix of coefficient 3 minus 2 and 3. Ax is the matrix in which the first column is this, the column of constants 1, 2, and the next one is this second column minus 2 and 3. And similarly in Ay, the first column is the matrix of A, 3 and minus 2. The first column is the column of matrix A, which is 3 and minus 2, and the last column is this column of constant 1 and 2. In this Cramer's rule, you have to learn what is Ax and what is Ay. And now we have to find the determinant of A, which is 3 into 3 minus 2 into minus 2, minus plus, it is 4. So 3 3s are 9, minus 4, it is 5. Determinant of A is equals to 5. Small x is equals to Ax whole determinant divided by determinant of A. Since Ax is this matrix, so we have to find determinant of this matrix and divide with determinant of A, which is 3 minus plus 2 2s are 4. 3 plus 4, it is 7 divided by 5. So x is equals to 7 divided by 5. Similarly, y is equals to Ay whole determinant divided by determinant of A, and Ay is this matrix. We have to find the determinant of this matrix and divide with determinant of A, and that will be equals to 3 into 2 minus 2 into 1 divided by 5, and it is 3 2s are 6, minus plus 2 1s are 2, 6 plus 2 8, and it is 8 divided by 5. The value of small x is equals to 7 by 5, and the value of y is equals to 8 by 5. So it is the solution according to Cramer's rule, and I hope so you understand these two examples, and let me know about your feedback, which method you learn to be easy and which method is easier for you people. So do let me know about in the comment section. You can get all the previous exercises and topics on this channel. Visit Explore More Mathematics and let me know about your feedback, and do help me creating more informative videos for you. So we will meet in the next video inshallah. Till then, Allah Hafiz.